Here we are in mid-chapter 6 exercises, numbers 10 through 15. Number 10, it looks like we're going to be simplifying, so let's be sure and factor all of these. So 5x squared already factored. X squared plus 7x plus 12, that's a trinomial leading coefficient 1, so we're going to go with the x and the x. And what times this to 12 and adds to 7, that's going to be a plus 3 and a plus 4. Okay, on the other one, this is a leading trinomial, leading coefficient not 1, so 2 times 21 is 42. It could be a 1 and a 42, 2 and a 21, 3 and a 14, and let me see, 6 and a 7. It looks like 6 and 7 add up to 13. So we're going to have 2x squared plus 6x plus 7x plus 21. And then we can take and cut that in half there. 2x, we get x plus 3. And take a 7 out, and we get an x plus 3 there. So we end up with 2x plus 7 times x plus 3. Good, that's what the bottom factors into. And then, of course, this 8xa cubed is already factored. So writing it all out, multiplication just means we can times the top and the bottom. So we end up with a 5x squared times x plus 3 times x plus 4 all over 2x plus 7 times x plus 3 times 8 times x times a to the third power. And let's see what cancels. 5, no, the x squared, one of those guys will go with that x completely. The x plus 3 and the x plus 3 will go away. And it looks like we're going to be left with 5x times x plus 4 on top, and then on the bottom, 2x plus 7 times 8a cubed, which we could put just out in front like that, 8a cubed. Good. Number 11. Factor the top here. Oh, that's good. X trinomial, leading coefficient 1. So we've got to see what multiplies to 28. Let me see, what multiplies to 28? That's 1 and 28, 2 and 14, 4 and 7. Oh, there we go, with a positive 7 and a negative 4. That'll do it. So x minus 4, x plus 7. That'll work on that one. Here we have a difference of squares. That's x minus 7, x plus 7. And then here, not a difference of squares. We got to pull out the greatest common factor. It looks like a 5a, and we're left with 3a minus 2. All right, so multiplying, that means we get to just connect the dots there. So we get a 5a times x minus 4 times x plus 7 over x minus 7, x plus 7, times a 5a times 3a minus 2. All right, so the x plus 7s go away. The a's go away. Oh, and the 5. And the 5. So we're left with an x plus 4 up on top over x minus 7 times 3a minus 2. I don't think anything else can cancel there. Good. All right, number 12. Factor the bottom here, and this is, what times is to 12? So 1 and a 12, 2 and a 6, 3 and a 4. Subtracts to a 4. That's a negative 6 and a positive 2, so that's leading coefficient 1, so we get to do just x plus 2, x minus 6. Okay, and on this one right here, x and an x, and what times is to 42? 1 and 42, 2 and 28, 3 and 14, 6 and 7. That subtracts to a positive 1, so that's a plus 7 and a minus 6, or adds to a plus 1, I guess. X minus 6, x plus 7. Okay, so multiplication, that means we just times them through straight across, and we get 5x to the 5th times x minus 6 times x plus 7. Good. All over x plus 2 times x minus 6 times 15xm. Okay, what can cancel? The x minus 6's are multiplying there. This x can cancel with one of those and leave 4 of them left. The 5 cancels with the 15 and leaves a 3. Let's rewrite this and see what we have. We have an x to the 4th times x plus 7 on the top. And then we have x plus 2 on the bottom. And we have a 3 and an m. Excellent. Good deal. All right. Let's look at number 13. Ooh, this guy looks big. On the bottom here, first, is there a greatest common factor? Yes, there's a y that can come out of there and get x squared plus 10xy plus 25y squared. Okay, now we have a trinomial leading coefficient 1. So we go x and x. Now what multiplies to 25y squared and adds to 10? You got a 1 and a 25 or a 5 and a 5? Yeah, it'd be a 5 and a 5. So this is x plus 5y. That's what will get us this 10xy in the middle. Oh, I just wrote the 10. 5y. There we go. That's the factoring of that denominator. Now let's look at this other denominator. There are two terms. Looks like we're going to be at a difference of squares, but not quite. That 3. Oh, there's a common factor there as well. We can factor out a 3x, and we get x squared minus 25y squared. That's a difference of squares. So this is 3x times x minus 5y times x plus 5y. Oh, good, good, good. Okay, so let's write down what we actually have here. We have 5x cubed y squared over y times x plus 5y times, we could say that's a perfect square and put a 2 right there if we wanted to, but it'll be easier to see what cancels if we have x plus 5y right here. Now times, remember this is division, so we're going to times by the reciprocal, so the top is going to be 3x, x minus 5y, x plus 5y, and then the bottom is going to be what used to be the top, 2x to the 4th, y to the 5th. Whew! And remember multiplication, we just times by and see what cancels here. So yeah, certainly the plus 5y and the x plus 5y go by there. How many x's do we actually have on the top? We have x cubed, which will take out 3 of those, and we have an x, which will take out the other one. So the x to the 4th completely cancels because we end up with an x to the 3rd, an x, so that's an x to the 4th on the top. Okay, on the y's, this y will cancel with one of those two, so we're left with 1. And then that one will cancel with one of those and leave 4 of them. Okay, so let's see what we got. We got 5 times 3 on the top, so that's a 15 x minus 5y on the top. And then on the bottom, we have a 2y to the 4th and x plus 5y. They look like they want to cancel, but they do not. Those are not the same factors, and certainly that 2 and that 15 can't cancel at all. So there's our answer. Number 13. That was an interesting one. Okay, number 14. Factoring, this is a difference of squares, so that's x plus 8, x minus 8, good. And on the bottom here, we can take out a 10x to begin with, and we're left with x squared minus 25, right? We took the x out, so that is x plus 5, x minus 5, again, difference of squares. That's nice to see that guy come up. So let's write out what we have. We have x plus 8, x minus 8, and we're over 10x, divided by, so we're going to do times by the reciprocal, so we get a 10x, x plus 5, x minus 5, good, over, and then, oh, we didn't factor this guy. Let me see, 32, what jumps to 32? So we have x, leading coefficient 1 in the trinomial. We have 1 and 32, 2 and 16, 4 and 8, They'll add to a positive 4. It looks like positive 8 and negative 4. So that's x minus 4x plus 8 there. Okay, so that's x minus 4, x plus 8. Remember, we're dividing by this fraction. That's why that top x minus 4x plus 8 got pushed down to the bottom. We're timesing by the reciprocal, and remember, that's all we do is connect those dots, and we're timesing. So anything cancel? Yes. X plus 8 goes away. The 10x and the 10 and the x go away. So we end up with x minus 8 times x plus 5 times x minus 5 all over x minus 4. Is that all we got left on the bottom here? Yeah, everything else canceled. Okay, there we have it. And then number 15. Okay, so let me see. The top here, this is going to be x plus 6, x minus 6. Good. What times is this next top one? What times is to 30 and adds to 11? 1 and 30, 2 and 15, 3 and 10, 5 and 6. So we got an x plus a 5, x plus a 6 there. Good. Does this factor? No. It's only two terms, x squared plus, and 5's not a perfect square anyway, so that's out of the herd twice. This one, though, that's a difference of two squares, so that's x squared plus 5 and x squared minus 5. Yeah, there we go. Right, x squared plus 5, x squared minus 5. Good, okay. So let's write down what we have. X plus 6, x minus 6, over x squared plus 5. Oh, don't forget that negative 10 over there. Yeah, almost forgot that guy. So we're timesing by, remember we're going to flip this on its head, x squared plus 5. And then x squared minus 5. Good. All over. And then we got x plus 5 and x plus 6. So what do we get to cancel here? The plus 6 goes, the plus 6 goes. The x squared plus 5 here and the x squared plus 5 there go. So we're left with negative 10 times x minus 6 times x squared minus 5 all over x plus 5. And remember, this negative could come out in front of the whole fraction if it wanted to. Great.